All right, what's up, everybody? So we're now going to move forward with the back tire. All right, so the back tire gets a little bit confusing, mostly again because of the drawing. It's not that it's designed to be confusing; it's way more about how to interpret these drawings, right? So we have a whole bunch of diameters here. We also have a section view, and the tool we're trying to get at is revolve. So what I like to think about with this is basically we are going to draw one subsection up here. It's going to look very similar to like an eye, and we are going to spin that around the middle of an axis. We're going to end up with an open space here and a closed space there. And the reason for that is because we want our axle to be inserted in there and to fit perfectly. It's actually called a limit tolerance, right? So some things we want to make sure we understand, right? Each one of these dimensions is actually very, very important. This line here on our eye idea is the same thing as this line, right? Our top view. So 16 millimeters, that's a dimension we're going to want to know. We also have to remember that from this corner to this corner is 6, and it says times 8. So that means each one of these is equal, right? 40 and 36. What that's trying to get at is that there is a 4 millimeter thickness all the way around this. If you apply the isometric drawing, our life is a little bit easier. We also have an open space. That's that diameter of 3 millimeters here. Like we got to update that drawing to include millimeters, but everything's in millimeters here. And it's all done to these center lines, right? So let's jump in and get started. All right. So something that I'm going to do that kind of may be a little bit tricky is I'm actually going to turn my axle on. And if you remember, our axle is a little bit bigger than 3. And on the tire, we're going to make our diameter 3. So because we're spinning this around, I'm going to come and write a sketch on the on the right view rather than the front view. Because if we think about this, if I draw my eye right here and spin it around my axle, that's going to be our perfect tire, right? So let's grab a sketch. We're going to do this on the right view. I'm going to do it over here. And we're going to get started. I'm going to jump in and do a construction line first. It's just a practice I like to apply. And I am going to apply the line tool, right? So I know that this is 4 millimeters. I know that this is 6 millimeters, and I know every single one of these is going to be consistent. If I come back, I know that from here to here is 10.5 millimeters. So I'm going to draw this to be 10.5 millimeters, right? Let's zoom out a little bit. I know that my line from here to here, like I said, is 6. I know that my line from here to here is going to be 4 millimeters. All right. This one's the tricky one. A lot of students struggle with this. This one is 16 millimeters, right? And the reason I know that is because of the drawing view right here. This line is the same as that line, right? Now this is just a lot of repetition, realistically. We are moving over, showing the exact same dimensions on both sides. If you do the math, you're going to understand that this is going to break down to be the exact 4 millimeters in between here. And I'm going to end up with a rectangle of 4, and then I'll close this off. All right, so this in general is what we're going to spin around, okay? And I have my revolution line. And if we moved forward to doing this, what you're going to realize is that we would have almost the exact thing that we want, right? Our hole is a tiny bit smaller because we want it to fit perfectly, like a limit tolerance, but it would be able to get out the other side, right? We don't want this to go all the way through. This is not a through hole, right? So that's where it gets a little bit tricky. We have some plastic that we want to kind of cap this, right? So I'm going to go back into this sketch and I'm going to edit it. And we're going to finish this up here. So the first dimension that I am going to apply is I'm actually going to dimension my my diameter of the hole, right? So we want it to be 3, so a radius would be 1.5. And you'll see that my center line is not perfect, right? Now, this is a tiny bit bigger than that. That's where we want. The other piece that I'm going to do is I'm going to grab my rectangle tool. And the reason that I'm going to grab a rectangle tool is because I need some more plastic here, right? So if this is 16 and I make my rectangle here 1.5 by 8, right? I'm going to end up, thought I did 1.5. Apparently I did not. I'm going to end up with the region that I want so that this is closed off. All right. So if I go through and trim that line now, I could have done a point. That also would have been nice. I end up with the exact region that I'm looking for on my drawing, right? So it's a weird looking eye if we cut it in half, but that is exactly what I want. So now when I go to revolve it, I'm going to end up with, here is my axis, and there, that fits in perfectly, right? I'm going to come out here and rename this to my back tire. Let's rename it first, back tire. And then I am also going to come out here and provide the physical appearance for the properties to be ABS plastic, right? So if I go to plastic, is there an ABS in white? Doesn't look so. Let's make it white. And if you'd like to move forward in making it black, we can edit the appearance so that it looks exactly the way that we want. So that one's a little bit tricky. Definitely one we would want to practice on. That's kind of why it's part of the project here. Won't be exactly like the tire we have in class, but like I said, drawing this next to the axle is definitely something that I've found helps students understand why it's so important for these dimensions to be the way that they are. I'm going to help your CO2 car run. Looking forward to seeing what you do next, and please let me know what questions you have.